Okay, so we are going to be achieving a very important project at this time. And this project, I hope you guys have seen my screen. Am I sharing already? I don't think so. Let me share now. Okay. So we are going to be looking at, I know we have seen a situation where our application is deployed and end users need to access this application. So what we'll be doing is that we are going to be configuring an Nginx web server. That's what we are going to do. We'll configure Nginx web server. So I'm going to be launching an Nginx web server. That's what I'll be doing. I'm launching an Nginx web server. Let me launch an Nginx web server. We are going to be installing Nginx web server on a Red Hat. So let me go for the free tier eligible Red Hat 8. T2 micro is okay. Storage tag name Nginx web server. So launching an Nginx web server. We're going to be using an existing security group CI/CD. This web server is coming up. We are launching this server in AWS. That's what we are doing, launching this web server in AWS for Nginx. So let me make sure this is a server I'm looking for compilation. Okay. This our Nginx web server is coming up. It's in pending mode. And this is the problem. You can now see the problem with VMware, right? These are what we are launching now is a virtual machine. You see how long it takes for this virtual machine to come up. You know, when we were creating containerized application, it took like you know, containers take seconds. Virtual machines take minutes. So containers are lightweight, virtual machines are heavyweight. So that's why, you know, any company you take containerization to is a big deal. Now, we have this application. In this application, again, we have 3 Tomcat servers. 1, 2, 3. These are our Tomcat servers. And in each of these Tomcat servers, we have their public IP addresses. This is the public IP address of the Tomcat server 1. This is it here. This is the public IP of Tomcat server 1. That's the public IP. Now, we go to the second Tomcat server. This is the public IP of the second Tomcat, and that is it there. We go to the third. I've already installed Tomcat on all these servers. So Tomcat has been installed in these servers. So now we have this project. We have this project. Oh, we have this project. So what I'm going to be doing is that this is the project that we have. So let me see. Making sure that I have everything together. Terminal. This is a project that we have. Let me come here. New terminal. So this is my Git bash terminal. We have this project, Nginx. So in this project, ls, I have Marvin web app. I've cloned this application. Wait a minute, cd dash, cd. So I cd into Marvin web application. I'm inside Marvin web app. ls target directory. I'm going to execute nvm clean inside the target directory. Okay, so the next command I'm going to be executing here, I want to create my packages. So I'm using Marvin to create these packages. nvm package command. We are creating our packages with Marvin. So Marvin will do validation, compilation, testing, and we'll be downloading plugins for all of that. And at the end of the day, packages are going to be created. So now we have these packages. So I'm going to be deploying these packages. Okay, the packages that have been created, ls target. Now it has created this package, Marvin web app.war. So I'm going to be copying this, okay, these WAR files. I want to copy them into my Tomcat server, all my Tomcat server. So I'm doing deployment. So for you to deploy in Tomcat, where are you supposed to copy for you to deploy in Tomcat? Where do we copy to deploy in Tomcat? We have to copy in the web apps directory. So I'm going to copy, okay, this file. I'll be using this command. This is the command, scp. Okay, now I want to copy any file that ends with war. So I want to copy the war file. So I'm copying this file, scp-i, this is my key name. I want to copy any file that ends with war into my Tomcat server. So this is the first Tomcat server. Okay, this is the first Tomcat server. Now, /tomcat/app. So I'm going to be calling this application /app, as you can see. So it's app.war actually, app.war. So I'm copying this WAR file. Okay, so I'm deploying this application because deployment in Tomcat is copying the WAR file, this file here, into the web apps directory. So I'm going to call, I'm deploying it as app.war. So enter. What am I to? Wait a minute. Lost connection. Public access. How did I lose connection to that server? It's telling me that I cannot access this server. I cannot. Can you see what is happening? It's supposed to be EC2 user, EC2-user. So it can't access that server as user. Enter. Okay, it's deploying. So I've deployed to the first Tomcat server. And similarly, I'm going to deploy to the second Tomcat server. So I have 3 Tomcat servers, which I'm deploying my applications to for high availability. So the second Tomcat server, this is it here. Just copying this guy. Second Tomcat server. App.war is EC2 user. So I'm just copying all of this, deploying. So this deployment, scp-i, I'm using this key to get authenticated. The file is found in the target directory. It ends with .war. I'm deploying it to this Tomcat server as app.war. Deployment is taking place. Deployment has taken place. Okay, I have to deploy again the third Tomcat server, and this is the IP address of that third Tomcat server. It ends with .84. Copy app.war. As a matter of fact, app.war. So this day, I'm copying this guy to do deployment using the scp command. Enter. Okay, I've deployed this application. You see that? I've deployed this application. Now, if I want to access this application, how can I access it? This is the application. What is the default port for Tomcat? I'll do something like this. The port is 8080 slash, the path is app. So if I run it like this, I can access, as a matter of fact, these are the options here. You can use app. You see that we can access this application like this for each of the applications. Let's try to see how to access those applications that we just deployed into Tomcat. This is our first Tomcat server. Yes, we can. We are accessing the application. This is the private IP of that server. You see that? The private IP address. It ends with what? It ends with 249. That's the private IP address. So let me access the next application. Now, I'm accessing the next application. Yes, I can access it. It tells me the IP address of the server, which is 141.141.125. You see that 141, okay, 125. So this server, this is the private IP. So we are able to access this application. Let me see the first server that ends with 172. 172. This is the server. 172. Let's see, we can access it. Yes, we can access all these applications. Now, what we want to do is that it is not a good security practice that when you want to access your application, okay, you access them directly where end users traffic, okay, goes directly to the application servers. That is not a good practice. So what are we going to do here? We are going to create a proxy, Nginx server. So Nginx is going to be acting as our front-end proxy such that end users traffic, you see that users cannot, okay, talk to our application servers directly. They must go through this Nginx web server. So that's what we want to achieve. So we have deployed this web server. Let's access it. This is the Nginx web server IP address. This is it here. No, that's not it. Let me go to the Nginx web server we just created, Nginx. So here's the Nginx web server. That's the IP. Let's access it on mobile extend. So this server is going to be running in our public subnet. So in the public subnet, we have this server, EC2 user. That's EC2 user, IP, the key, CI/CD. So I'm accessing Nginx web server. Let me detach it. So here is our Nginx web server. Now, we have to follow this analysis very closely, very important. So we want to install Nginx to act as a proxy, which implies end user traffic is going to be, routed by the Nginx web server. So this guy is acting as a proxy, it's acting as a load balancer. It receives the traffic from clients, end users, and route it to our backend application, and our application will talk to our databases. Now, look at what we have here. So this is our Nginx. So I'm going to create, let me just do sudo hostname. Let me assign a hostname to this server. Sudo hostname Nginx. Okay, now let me become the root user. Now I'm root user. As root user, we are going to install Nginx as root user. Nginx.sh. How do you install Nginx in Red Hat server? You see that? So I'm going to run this command first. Just to install the Perl repo in a Red Hat server. So we are able to access our applications again as we saw. is not allowing us to run that command. I'll just do yum install Nginx. That's okay. It's going to install Nginx for us. Yum install Nginx -y. Yum install Nginx -y. So we are installing Nginx web server. Okay, the next thing we are going to do, we'll enable Nginx and start Nginx. So enable Nginx, systemctl. So let's start Nginx, start Nginx. It has started. Let's check the status. Is it running? Status, Nginx is running. So here's our Nginx web server. So if you want to access this web server, if you want to access our Nginx web server, this is the public IP. You access it on port 80. So all we are going to do is we come here, enter the IP. Here's our Nginx web server administrator. So this is the Nginx web server. If you want to add content, you can do something like this. But this is the Nginx web server. Now, it says that the configuration file is found here. This is the Nginx config file. This is where it is found. So let's go back. Let's go back and see what, you know. So now, let me cut this config file. This is the Nginx config file. You know, I mean, we use it as a proxy. So what I'm going to do next is that I'm going to create a backup for this Nginx web server. We'll create a backup. So we'll run a command. Now, so this Nginx, okay, this Nginx config file, I'm going to back this file up. So I'm creating a backup with this command, sudo move. Okay, so I've created Nginx, etc nginx.config.backup. So I've created that file. Therefore, if I try to cut Nginx file again, it cannot find this file anymore. It can't find the file. You see that this file cannot be found. So what I'm going to do is I'm going to recreate this file with our own configuration. So we can do vim. Vim is not found. So let me vi. Now, this is the file. We are creating a new file. Now, this is the content you need to copy for this new file while creating it. This is the content. So this is all we have here. Now, this is the information of our Tomcat servers. Let me just delete this wait here. I'm going to explain what that means shortly. Now, we have events that are going to be taking place here. Okay. Now, we have different Tomcat servers. There could be 100 Tomcat servers here. Okay, but now we have 1, 2, 3 Tomcat servers. They are all running on port 8080. If, for example, I've changed one of my server port to port 80 or 8888, it's going to be 8888. You see that? It's going to be 8888. Please avoid not to be kicked out by connecting to this class with your video. It's important. Security is in effect. Now, so these are my Tomcat servers. Let me show you something. These are my Tomcat servers. For example, if I come here, you are going to see the different Tomcat servers that I have. Tomcat server 1, that's the private IP. It ends with 125. If I go to the next Tomcat server 2, private IP ends with 29. The third, okay, and this is the port, but this port is wrong here. This port is supposed to be 8080. I've not changed the port. So this is the port that I have here. So now it is going to listen on port 80. So this is what we have. So look at what I'm going to do. I'll copy all of this configuration. So if you configure this, the only thing you are going to change will be your server information. So I'm copying all of this. Come here. Now, I'm going to paste it in here. So this is what I have here for my back-end server. So in the front end, I have my Nginx server. Any traffic that comes okay, it talks to the Nginx server, and it's going to be routing it to all of these Tomcat servers. So this is what we are going to have. We have something like this. This is Nginx Web Server. So since we have this, once you do this configuration, we need to make sure that the configuration is valid by, okay, executing this command, Nginx-T. Let's check. Okay, the configuration is okay. You see that the configuration is successful. Everything is fine. Syntax check, test is fine. So since we have this, we are going to reload our Nginx. I'm not using sudo because I'm running as root user. So root user. So I've reloaded and I'm going to restart Nginx. Now, I'm going to restart my Nginx server. Once I restart this Nginx server, let me try to see if I can access my web server again. This is a web server. Am I able to access it? I'm told bad gateway. When you are told bad gateway here, okay, it's because Linux, okay, there is a security in, okay, Linux called Linux. At this time, it is enforced. So all you have to do is to, okay, run this command so that you can allow that proxy server to route traffic. You see that? So we are going to enable this particular security with the help of this command. So let me show you how we run it. You run it like this. You see that? Okay. That has been disabled. Therefore, if I try to access this server, I don't get bad gateway anymore. It is already routing traffic to my back-end application. So now, remember it's /app. You see that? So from our web server, it is routing traffic. You see that? Now, it has routed traffic to which of the servers? Look at their IP addresses. The first one that ends with 79. Now, let me refresh it. Now, it has routed it to the server that ends with 249. As you can see here, okay, let me see. Did I copy it? Okay, now, 249, this is it here. You see that here we have 29, 125, and 279. So it is routing traffic accordingly. You see that? It routes to the server that ends with 125. So please take note, it's very important. Now, when we look at AWS Web Services, we are going to study a very important concept called virtual private cloud, where you are going to realize that in this architecture, okay, now our front-end load balancer will be in our public subnet, while our application servers and databases will be running in the, okay, private subnet. So this is what is happening. So now Nginx is acting as a load balancer. Now, the question is, how does it load balance our traffic? You see that? How does it load balance the traffic? Now, the default option that it uses to load balance traffic is what we call round robin. These are the options that we have. Now, here, requests are distributed evenly across the servers with server weight taken into consideration. This method is used by default. So now, the question is, what are the load balancing methods that can be used? The default option is round robin. So what happens is that now Nginx is going to be routing traffic to these back-end servers, as you can see, okay, depending on the load. So now traffic is going to be distributed what? Equally. So please take note, it's very important. This is what, okay, we have been able to achieve. But now there are other options that we can still be able to achieve. Okay, for example, we are part of round robin, we have what we call lease connection. Now here, a request is sent to the server with a least number of active connection. Again, with server weight taken into consideration. So this is what happened. Lease connection, like For example, okay, we had an incident with Facebook today. Now, Facebook has like 1,000 servers, and they have a web server that is routing traffic to all these servers. Now, the idea is, if you have a particular application server where the Facebook app is running, what happens? Now, end users, if it has a lot of traffic and there are other servers, Lease Connection does what? Lease Connection will search for the servers that, okay, that does not have high traffic, and will be routing traffic to the servers that have the least number of, requests. So please, this is what you take note of. And one other option is IP hash. IP hash is very important because, for example, now, when end users are trying to access your application, now, if you have an IP address that is coming from Canada, for example, okay, now, Facebook will know by default that this is a Canadian IP. Probably you have IPs from Africa or Asia, whatever. Now, it can decide that any IP address that has this octet, for example, which implies it comes from a specific destination, it should be, okay, that is, okay, it's like, we have something like this, right? Now, these are our app servers. We could decide that, now, IP addresses from Africa, let it go to app server 1. IP addresses from Asia, app server 2. From the Americas, app server 3. That is what we call IP hash. We can use that. So it's very important to have that understanding. Now, there is one other thing that you should understand as far as all of this is concerned. Now, this is our servers. Okay, now let me go back to this file. If you look at this file, let's assume that one of our application servers needs, okay, we need to do like, some maintenance on it. We want to carry out maintenance in one of these application servers. If we are going to carry out maintenance, okay, how are we going to manage the maintenance period? Now, if a server has, or for example, now something is happening with our server, like I think there was a day here where we tried to run Docker and there was no resources available for that particular Docker, okay, host server. Now, we have that kind of a situation and we want to do upgrade for this particular server. We want to do upgrade. How can we do that? We can just come here and put down. You see that? If I put down, it means that this server is down. So no traffic will be routed to this server. Why? Because we are doing maintenance. Okay, or we are trying to patch the server. So the server is down. If I save this, take note, this server ends with 125. Now, let's try to, okay, once you do that, you need to still make sure that you check, we have to run this command to ensure that the configurations are valid. Once they are valid, we have to reload our Nginx, okay, and we have to restart Nginx, systemctl, restart Nginx. So that has been done. So now that we've done that, remember, that server ends with what? That server ends with 25. So if I come here, if I refresh, can you see? We have 29.29. Just begin to check if you are going to see that particular server coming up again. Let me, it's reloading. Reloading. You see that? Let me come here, reload. Let's share this spot here. We have point. So this one is down. I've put down here. See that? That server is down. So actually, when the server is down, we are going to configure it as such, down. So let me see. Now, traffic cannot be routed. Let me try to access it on a different browser and see what we get. To access on a different browser. Now, what do you realize? We have the IP address is 249. Remember, different users will be accessing this application. Now, the IP address here is 29. There's just no way we are going to have 245. Let me try again. Open another browser. Now, here I have 29. Okay. Why? Because the other server that has, okay, this specific IP address, the server is down. So the server is up for maintenance. So please take note. So now, let's assume that we want a particular server to receive more traffic. You see that? We want a particular server to receive more traffic. Remember, we are going to put a server down, configure it to be down when we are trying to do upgrade or patching. But if we want a server to receive more traffic, okay, how are we going to configure that? Now, let's assume that Tomcat server 1, now, this server has about 8 GB of RAM. Okay, now let me go for Tomcat server down is down for maintenance. Now, Tomcat server 1 has 8 GB of RAM. Tomcat server 2. Now look at something. Because in real time, Tomcat server 2 has 64 GB of RAM. Now, this is a real company environment. So it is common sense that if this guy has more server resources, it should be assigned. So this is the RAM memory. That's the RAM. You see that? Here's the RAM. So now, probably for CPU or disk space, EBS volume, the EBS volume here is about that is 256 GB, whereas the disk space here is about 3000 GB. Now, look at the difference in resources. So what do? Since, okay, Tomcat server 2 got less resources and Tomcat server, okay, 4 or 3 got more resources, what we want is that if we have 5 requests, that is to say, if we receive like 4 million requests, or let's say 5 million, if we have 5 million requests, then we want a situation where 1 million goes to what? Tomcat 1, okay, and 4 million, and 4 million goes to Tomcat 3. So we have something like this. 1 million requests goes to Tomcat 2, okay, and 4 million goes to Tomcat 3. We are going to use the wait option like this. The wait option. Therefore, in the server that has more computing capacity, okay, we are going to assign a higher wait value. So let's go back to that file. Higher wait value. So now, in our Tomcat server 3, we have something like this. Under wait, okay, we are going to be assigning the weight of 4 because we want more traffic to be routed to this 4 times the traffic that goes to Tomcat, okay, server 2. So now let's save and quit. Once we save, again, I'm going to check if everything is okay. Configuration is fine. We are going to reload Tomcat and we are going to restart. Oh, sorry, we reload the Nginx and we restart our Nginx web server, which is acting as a proxy, routing traffic and acting as a load balancer. Please take note, very important. So with this now, if we are trying to find out how our application is routed, you see that you realize that more of the traffic is going to the application server, okay, that ends with what? Much of the traffic, because what do we have? Which of our server was down? Let me come here. Which one is down? Based on our configuration, we have app server 1 is down, and we are assigning a higher weight value to this guy. So 249 is going to be receiving 4 times the traffic. You see that? 4 times the traffic that, okay, 29 will receive. Why? 125 is down for maintenance. So please take note. So this is what I wanted to explain to you to have a good understanding. So, you know, if you were going to explain this at any point in time T, you see that this is what you should be explaining to them. So in real time, we will not be exposing our application directly, you know, for end user traffic. We are going to use a proxy server. So please take note. It's very important. Very important. So with this, you are able to, okay, access your application with relative ease. Any question? Any question? Okay, I see Divine. You can go ahead and ask a question.
Yes, thank you very much, Prof. So we have seen two methods of routing traffic from the proxy server to the back-end application. So
we saw three methods. We saw IP hash, lease connection, and round robin. That's what we saw.
Oh,
IP
okay.
hash, lease connection, and round robin.
Okay, I think I paid attention to round robin and maybe IP hash. Okay.
Okay.
So the only three methods, right?
Yes.
Okay, thank you.
Hello, Prof.
Yes, please.
So that means I know we have load balancer in AWS.
Of course, we have load balancer in AWS.
Yes, so that means if we are not using Nginx, we can use the AWS load balancer?
Yes, and that's what we'll be seeing when we get to Kubernetes and AWS itself. Look at it, but it is very important you first of all understand the picture, right? Because what does the load balancer do? You see that, what is this web server? Why do we need a web server or load balancer?
Mm-hmm.
You see that, you realize that, you know, to start with, it does what? It does load balancing, which is very important. It does load, okay, balancing. It's also good for security. You see that it's good when, you know, if we're going to do like patching and upgrade of servers, you see that because patching and upgrade, patching and upgrades, because since we have, you know, traffic can be routed to the servers that are running. So patching and upgrading of our servers. So we have, you know, options like this. And when it comes to security, as we are going to be seeing, load balancer is going to, you know, do like if they're because now look at something, please. As we have seen already, we have users. Now, when users are trying to access your application, we have a load balancer. It stands in front of your application. You now talk to your app, okay? So it receives the traffic from end users, take it to the app, and from the app, we have our database. This is how it goes. So now, this guy is acting as a layer of security where, you know, it does stuff like SQL injection, where if anybody is trying to hack into our app, okay, it can be stopped at this stage, which is very important. So these are some of the importance of load balancing, and just the fact that it can balance the load, and it also does health check, as we are going to be seeing. It performs health check. You see that? So now, if it is load balancing load to like, let's say about 30 servers, it's going to make sure that it does not route traffic to a server that is not healthy. So it runs health check in the back end. That's how it goes. Okay, let's take a question from Prince. Is that Prince?
Oh, yeah. Hi, Prof. Thank you.
You're welcome.
Yeah. I know you've not differentiated the load balancer, and in terms of this, does it matter? I know it serves both as security and for performance, right? Integrated with the Nginx, right? So, yeah, that's right. So does it, do we consider what type of load balancing it is, or it doesn't matter at this point?
No, at this point, we are not really considering the type of load balancer. But
okay.
For you to explain in an interview that you have experience in Nginx web servers, okay, is equally important.
Okay.
Yes, because we are going to be doing other managed load balancer like ELB, elastic load balancer
application, okay. And yeah,
but
okay.
Once you understand this aspect of it, that equally will be very easy for you to understand.
All right, thank you.
You're welcome. Let's take a question from Richard Pius.
Thank you, sir.
You're welcome.
My question is this. You were speaking once and said the Nginx will be in the public subnet.
Yes.
My question says, if there are two availability zones,
yes.
Does it mean that you will have two Nginx in the two availability zones?
Okay, good question. Now, when we do AWS, okay, you realize that now, if you have a VPC, which is a virtual private cloud, that is your private network. This private network, you can have about even 5 subnets. You see that? You can have 5 subnets. Now, depending on the region, okay, let's assume that you have 6 subnets. And this 6 subnet, right, we have 3 private subnets. 3 private subnets. And we have 3 public subnets. Now, take note, because this is something we are going to still look at. This is 3 public subnets. 3 public. Now, if you have something like this, these are the subnets. Now, in AWS, okay, global resources, right? You have global. From global, what else do you have? You have regions. Under regions, what do we have? We have AZs, availability zones. Now, watch what is happening. Inside this availability zone, we have data centers. So your data centers are inside the availability zone, AZ. So what is happening is that when you create a VPC where you want to, okay, create your, where you want to launch your resources, this VPC, now assuming that you are going to create your VPC in US East 1, which is West Virginia, US East 1. Now, US East 1 got 6 different AZs. There are 6 different availability zones, which implies that I can create my 6 subnets in all these availability zones for high availability. You see that? To ensure what? High availability. I can do that. So if I want to get high availability, okay, now, if I have my Nginx web server running in a public subnet, take note that all these servers are in the same VPCs. So they are in the same network. You see that? So since they are in the same network, Nginx web server can load balance traffic to all the servers running in all the both private and public subnets. It can achieve it because they are in the same network. But now, assuming they were in 2 different networks, like we had VPC1, okay, we have VPC1, and we are also having VPC2. Okay, now, how are we going to ensure this connection happens? We are going to do what we call VPC pairing, pair these VPCs together. So that then now, even though they are in different networks, when you pair them, okay, you want to put them in the same network. That's what happened. In that case, you will still be able to use a web server and load balance traffic, okay, across all your servers, because this is high availability. And this is the advantage of using AWS. Okay. I hope your question.
Okay.
Yes.
My question is, the availability zones there are 2. So I can still use that one public subnet Nginx to route to the 2 availability zones.
Now, yes, you can do that. Let me also explain something where people get confused. Now, look at something, please. This is an availability. So it's just like you go to Virginia in the US, right? You have different cities in Virginia. Now, in those cities, AWS has different availability zones where their data centers are, it's like where they have their data centers, which means that those computers are, okay, are running inside those data centers. Therefore, if I create an EC2 server for Tomcat, if I create my virtual machine, my Tomcat VM, okay, my Tomcat VM, which is what? My Tomcat VM is an EC2 server. You see that? An EC2 computer, right? When you create this Tomcat VM, it is running in an availability zone, but under your VPC. Okay. So now, assuming that you created a Tomcat VM in availability zone 1, because In US East 1, there are 6 AZs. So now you have 6 different servers in each of the availability zones. Or you have 18 servers, 3 in each availability zone. Now, your web server, okay, running your public subnet can route all those applications, okay, can route, okay, traffic to all those 18 servers or those 18 EC2s. Okay, you can be able to achieve that, yes.
Thank you very much, sir.
You are welcome. Okay, let me take a question from Siren.
Okay, thank you very much, Prof. I was wishing to find out. So this is basically, or should I put it this way? So you can basically do this configuration and create an image, a Docker image, which you can use it to deploy and link with your Tomcat or a Tomcat image as well.
Yes, don't worry. What I have explained here, we are going to see the amplified version in Kubernetes. It's just that you may work in a company that is not yet implementing microservices as expected. You see that? Because the application we deploy them in what? In virtual machines, in VMs. You see that? So if you work in that kind of a company, or you have tasks that relate to monolithic application running in virtual machines, you should understand how that traffic can be routed. Understanding this will make you to easily understand Nginx when we get to Kubernetes.
Okay, thank you.
You're welcome. Okay, so let me take a question from Mike.
Yes, thank you, Prof. I was wondering if a user wants to access, any of those applications, are they going to be using their individual IPs, or going to use a virtual IP, or they're going to use the IP of the engineer?
Good question. Now, he's asking a good question, but if you look at the problem we have solved now is that before, when users were going to access this application, they had to access the individual server IP, but we have put all of them under one Nginx web server. So all the traffics are routed via that Nginx web server. So the question he has asked is a normal question that now, look at how our users are accessing the application. Does it make sense for you to give this kind of, just imagine you want to enroll in Landmark and they give you, go to our Landmark web server, type http://3.89, you see that this will not make sense, right? It doesn't. So now, like if you want to enroll in Landmark, what are you do my Landmark Tech, right? My landmarktech.com/register, something like that. That's what is expected of you. So the question is, how can we configure such, now there is a service in AWS which we are going to do when we get to AWS called domain name service, Route 53. Route 53 is DNS, which is domain name service. Very important. This is Route 53, DNS, domain name service. So if you have DNS, what we are going to do is that, look at something, please. We are going to go to our Route 53 and create what we call, we are going to create a hosted zone. So in that hosted zone, we'll be routing the traffic. Now, instead of, users to type this information, they can type something like, they can type something like app.com, and traffic is going to be routed to this back-end application server. So let us achieve that, because I think we have that already. Let's achieve it. Let's see how we can configure Route 53. This is it here. Now, this is Route 53. So in Route 53, this is DNS. I have 2 hosted zones because I've bought some domain names. Now, I think I should have like 3 domain names here. Landmark. What is happening? I have 2 domain names. landmark.org. Okay, now I have this www.landmark. Let me create a hosted name, edit the A record. Okay, now this is my server IP address. This is my server IP. Okay, so I want to edit this A record here. So now, if you type www.landmarkmu.org, you see that it's going to route traffic to that web server. So let me save. I've saved that now. So this is, if I want to give end users, this is what I'm going to tell them to do. End users, no point for them to type, you know, they should just do www.landmarkmu.org/app. It will take them to our application. That's all they have to do. This is you configuring your DNS. Very important. So let's see if we can access that using DNS. Are we able to access it using DNS? Is it working?
So it will take them to the Nginx server.
Yes.
All right.
So what is happening is that a hosted name, like this is an alias, right? Because it's just like your name is, Paul, okay, they call you P, and you see respond, because that is your name. You know what I'm saying? So what happens is that now, if you want to access this application, either you type the Nginx server IP address directly, or you type this domain name that we have created. This is a public domain name. So when end users are trying to access this application, this is what they are going to type. Now, when they type this, like, there is this interview question that they always ask: what happened when you type app.com or google.com? What happens when you type google.com? Now, what happens is that when you type like app.com, for example, when you type this particular, okay, now, if you type this information that we have here, landmarkmu.org, what happens is that in the back end, you are going to query, okay, global DNS. So you query global domain name service. And what is happening is that there is a command in the back end that runs called, okay, name service lookup, NS lookup. So it is going to be searching the server. You see that it searches for this server. For example, let me show you guys something. Now, so if I run NS lookup, let me run NS lookup command. Let's find out where traffic is going to be routed. NS lookup, okay, this is what I want to run. NS lookup, enter. Wait a minute, NS lookup command not found. Did I write the command correctly? Lookup.
That's in Linux. I don't know why you're going to take that command.
Pardon? That's supposed to work, right? It's supposed to work. Let me see.
Yes, it's supposed to work.
Space.
It's work, right?
Let me try it on my Windows laptop and see. NS lookup. It's working. You see that? I ran it in which server here? This is my Windows server. What am I told? I'm told that NS lookup, www.landmarkmu.org, this is the address. Is that the address?
Yes.
3.89.221. This is the address of our Nginx web server. Even if you as well, if you run this command now, it will tell you that, okay, this public DNS name is pointing to this, okay, web server. That's where it is pointing to. So please take note. So once you type google.com, it's going to query global DNS, searching for the web servers that are associated to this host name. And once it locates that server, immediately, okay, traffic will be routed to that server. So please take note. Very important. Now, let's do NS lookup google.com and see what we get. Google.com. Let's find out the web server that Google is running. Can you see the web server? That's the web server, name and address. Now, let's check Facebook. What could have happened to Facebook? Facebook, facebook.com, name service lookup. You see that? That's equally Facebook. So please take note. Do we have any other question?
Yes, Prof.
Thank you, Prof.
Sorry.
Okay, Tenasha, ask a question.
It's not Tenasha.
Tenasha?
Sir, I had a question regarding you spoke about the servers. I know it's not directly related to the software and the applications, but just out of education-wise, what determines a server being unhealthy and that may cause it to fail?
Okay. That's a very good question. Now, you know, there could be a spike in the CPU. You know what I'm saying? Let's assume that a lot of processes are running in that server, or the server is receiving a lot of traffic. You see that? That server may not be healthy to receive additional traffic. So that is one of the reasons that can make a server to be unhealthy. Now, one other thing is that this server is a Tomcat server where the applications are running. For some reason, okay, the Java process is not running in your Tomcat server. Remember that if Java does not run in Tomcat, Tomcat cannot start, right? So if you deploy application, you cannot access it now. Java process, okay, if Java process is failing, or if Java process fails, okay, your Tomcat server will be unhealthy. So anything can make the server to be unhealthy. And as such, the web server will not route traffic to an unhealthy target. And that is why, okay, when it comes to load balancing, it's very important with Nginx because it has all these advantages. Yeah, so that said, I think we are going to end here today.
Sorry, Prof, just one question. The reason why I can't raise up my hand is because my reaction doesn't have that.
Okay.
I don't know. So, just a quick question. Please, can we also, the same way we installed Nginx on Red Hat, can we do it on Ubuntu?
Yes, we can.
Okay, so my second question is why would you always prefer we install those applications on Red Hat? Why not using Ubuntu?
Yes, it's just because I want you guys to understand both Red Hat and Ubuntu. When we install Docker, we install Docker where? Ubuntu.
On Ubuntu, okay.
Yes, and tomorrow we are going to be configuring Kubernetes on Ubuntu.
Okay.
Yes, so but it's good for you to have exposure to both Red Hat and Ubuntu. Very important.
Thank you.
You are welcome. So please, tomorrow we start with Kubernetes. Exceptionally, I had to have this other additional information for Docker because what we have covered today and what I shared with you as videos, class 24 did not have that, for the last class. So, but I've seen a lot of tickets on our senior support engineer help decks, and I just deemed it necessary that some of these projects, I'm going to be doing them and just sharing the videos with us so that we have a good understanding. So tomorrow, exactly 7 p.m., we are going to be starting with Kubernetes. Please, a lot of folks join the class 10 minutes late. At times I wait to have at least 100 people connected to start the class, but it's very important for you to join the class as early as 7. I'm going to be sharing some notes in the morning so that you can start going through the notes for Kubernetes before the class at 7 p.m. tomorrow. So that said.
Last question, Prof, please.
Yes.
I think most people complain that we don't have the running notes for the Docker volume and the Docker Swarm.
All the running notes were shared. Just check it out. You realize that the notes are there.
Okay, one other last thing, Prof, please, sorry. I had an issue with my Docker volume. I mean, with the Docker Compose file.
Yes.
At the level of volume, it said I couldn't do an array. I can only do a mapping.
Yes.
For the external volume, I tried, but it didn't work. So I had to delete that external volume aspect before I could run my Docker Compose file.
Okay, now the fact is that when you do external, like volume external, it means the volume has already been created. If the volume has not been created, you have to go and run docker volume create. You create that volume before you can rerun that file. But I will equally share the Docker compose files that we have used today. I am going to share them so that you can use those as well to compare it to what you had and for effective practice.
Okay. Okay.
Okay. Good night, everybody.